Okay, this next video is on LHopitals Rule, or Hopitals Rule. You don't have to pronounce the L, but this is used, it's a great tool for finding limits that are often difficult to evaluate, and it can also help with determining limits at infinity for asymptotic behavior. We will use it for curve sketching in the next section as well. When evaluating limits by direct substitution, there are 7 expressions known as indeterminate form. And those expressions are the ones below: 0 over 0, infinity over infinity, 0 times infinity, 1 to the infinity power, 0 to the infinity power, infinity minus infinity, and infinity to the 0 power. Now, these 7 indeterminate forms, possible pop quiz coming up when you guys return from intersession, so make sure you know those 7 indeterminate forms. Well, Hopitals Rule states that when f of x divided by g of x has an indeterminate form at x equal a, then we can replace f of x divided by g of x by the quotient of the derivatives f prime divided by g prime, which is exactly what this next box is saying. Assume f and g are differentiable on an open interval containing a, and that f of a and g of a equals 0. Also assume that the derivative is not equal to 0, and then the limit of the original functions is equal to the limit of the division of the derivatives. Now, if the limit on the right exists or is infinite, this conclusion also holds if f and g are differentiable for x but not equal to a, then f of x can be plus or minus infinity and g of x can be plus or minus infinity. And this rule is also valid for one-sided limits. So make sure you highlight that box. It's an important box. So let's go through some examples. I apologize for that and my left-handedness. So for the first one, we're given the limit of 2x squared minus 9x minus 5 over x minus 5 as x is approaching 5. Well, our f of x function is 2x squared minus 9x minus 5. Our g of x function is x minus 5. Now, if we plug in x equal to 5 on both of these functions, we're left with f of 5 over 3 of 5. 50 minus 45 is 5 and 5 minus 5 is 9. So we end up with 0 over 0, which is one of our indeterminate forms. So we're going to actually have to find the derivative of these functions. So f prime will be 4x minus 9. 3 prime is just 1. So now if we take the limit as x approaches 5 of 4x minus 9 over 1, then that's just 20 minus 90. So now, again, f of x is your top one, g of x is your bottom one. Now, there's some other types of examples that we're going to continue to do. Example 3 says repeated use of LHopitals Rule. So again, we're going to start with our f of x and our g of x. So now, as x approaches negative infinity, f of x will approach positive infinity. G of x will also approach positive infinity. So you're going to end up with infinity over infinity, which is an indeterminate form, so we're going to have to find the derivatives. So f prime will be 2x, g prime will be negative e to the negative x. But then again here, if we look at the limits of this is just a straight line. So f prime will still approach infinity. This is just, it's an exponential function. When it approaches negative infinity, it will still approach infinity. So again, we still have infinity over infinity, which is not what we want. So we're going to have to take the derivative again. So second derivative will be 2. Second derivative would be e to the x, negative x. And now if we take the limit of these functions, as x approaches negative infinity, that one's just a constant, so we have 2 over e to the negative x. You have 0 over over infinity. 0 is overpowering, so your answer to that one is just 0. And then graph this equation in case it doesn't make sense. Example 4. If we do our f of x and our g of x, try the original one. If you end up with an indeterminate form, you take the derivative, try direct substitution again. If you end up with an indeterminate form, you keep going until you can finally get a solution to the problem. Example 5. Now we're going to do some trig. And we're going to split this up into two fractions. So it'll be direct substitution here. Once again, we get cosine of 0, I believe is 1 over 0. We can't divide by 0. We end up times 0 over 0, which we can't do, so we're going to take the derivatives one more time. So we're going to have the limit as x approaches 0 of negative sine x over 2 times the limit as x approaches 0 of cosine x over 2. This first one will give us 0 over 2, which is just 0, times 1/2, which surprise, surprise, gives us 0. As a matter of fact, we actually could have done this from this first derivative. We have, no, because of this bottom one, you can't divide by 0, so we couldn't have done it there. Never mind. Moving on. Example 6. Direct substitution here. So we'd end up with ln of 1, which is 0. Ln of 1, yes, is 0. Minus 1 is a negative 1, plus 1 is 0, over 0. So direct substitution is 0. So we're going to have to take the derivative. So the limit as x approaches 1, derivative of the top is 1 over x minus 1 divided by the derivative of the bottom, which is just e to the x. Here, if we substitute in 1, we end up with 1 over 1 minus 1 divided by e to the first power. 1 minus 1 is 0 over e to the 1. Since the 0 is on top, it's overpowering, so our final answer is just 0. We didn't have to go too far into that one. But if it wasn't that simple, we would have had to take common denominator up here, then do quotient rule, and then find the derivative of the bottom, and get into this ugly mess. So, it's a good thing that one didn't come out that way. 2 more examples. here, we're gonna take, can't really substitute in infinity, so we're gonna take so the limit as x is approaching infinity, which we don't even need to. If you notice this function, they have the same degrees, the polynomials. This one's a 3/4, a 3, this one's also a 3. So for these particular cases, anytime that you're taking the limit as it's approaching infinity, if the degrees are exactly the same, all you need to do is take the leading coefficients. So really the answer to this problem is just 3/4. And you're done. So that one worked out pretty nicely. However, if you look at example 8, the degree to this one is 2, the degree to this is 2x, so they don't match up. So we're going to actually have to take the derivative here. So limit as x approaches infinity of 8x minus 3 over 2e to the 2x plus 1 over x. Well, once again, we can't substitute in an infinity. The degrees don't match up. So we're going to take the derivative one more time. So limit as x approaches infinity of 8 over 4e to the 2x minus 1 over x squared. Took the derivatives of the bottom separately. Well, from here, if we look at this as a function, it's just a constant. So really, as x is approaching infinity for 8, you have 0 over some number, which really doesn't matter because the 0 is on top, balances everything out to 0. Hopefully that made sense, and that's the end of this video.